Congratulations on finishing the first full unit of Algebra 1. So now we are moving into the second unit, which is totally different than if we were in person. There's only a couple lessons from this unit that we will do, and it largely revolves around statistical analysis. So we're going to look at some scatter plots and some other things, and we'll just make some estimations and some other things around that. So this would be the 12th lesson of this, but we skipped 1 through 11. So if we look at the objective for today, students will distinguish between scatter plots that display a relationship that can be reasonably modeled by a linear equation and those that should be modeled by a nonlinear equation. So again, we're going to look at scatter plots and see whether they look like it would be a linear line that would connect them all, or equation, or a nonlinear equation. So if we check out this information here, go ahead and tell me in the chat what you notice. What is this talking about? What is this telling us? Again, a lot of this unit is going to be done on your own, so I'm not going to be giving you as many answers as I have in the past. I really want you to tell me what you see, what you notice, and what is going on. So again, tell me in the chat what you notice about this table. All right, so if we look at it, these are all cities in the United States, and it talks about their elevation above sea level and the number of cleared, partly cloudy, and cloudy days. So the table here and the graph that we will look at are going to try to connect whether elevation has anything to do with the amount of clear, partly cloudy, and cloudy days per year. So here is the scatter plot on your, so again, the scatter plot is the points from this table just graphed. So each one of these red dots represents one of these points that is plotted here. So it says, here is a scatter plot on data elevation and the mean number of clear days. So it says, do you see a pattern in the scatter plot? Or does it look like the points are totally scattered or spread throughout? So again, the closer they are to creating a linear line or relationship, that would mean that there is some type of pattern, and the more spread out they are means that there would not be a pattern there. So your job for number 1 again is to tell me whether you notice a pattern in this data. And if we look closely, what we're trying to see is if the elevation is lower, right, are all the dots on the left, or the average of the dots on the left, lower than the average dots on the right? If so, that would say the lower the elevation is, the less number of clear days there are. So again, if it's a higher elevation, are the dots higher? That would mean that there are more clear days. And it looks like, yeah, it looks like it would be linear. It looks like a line would be starting lower on the left and rising to the right, meaning that the higher the elevation is, the higher above sea level a city is, the more clear days they have. So then it says, how would you describe the relationship between elevation and mean number of clear days in the 14 cities that are listed there? And again, it says that is, does the mean number of clear days tend to increase as elevation increases? Or does the mean number of days tend to decrease as elevation increases? So we really did just touch on that. Again, if you look from left to right, it's not a huge difference, but it does look like as the elevation increases, the number of clear days also increases. And then number 3 says, do you think a straight line would be a good way to describe this relationship? So if we average these all out, would a straight line be the best way, or would it be a curved line or a circle or something else? And if we think about that, so again, do we see a pattern? It doesn't have a strong pattern, but there's definitely a pattern. The data does look somewhat scattered, but it does look like generally moving from left to right, it is increasing. And then again, that also goes to explain number 2 here. As the elevation increases, the number of clear days generally increases. And then the last one there, again, although it's not a strong pattern, strong would mean that all the points were almost exactly on a line. A straight line would describe the general pattern that was observed. So I'll give you a minute to write these in. Again, you're gonna, in the black boxes between each question, you'll just click and you'll write your answers in. It doesn't have to be word for word what I've described here, but you are going to put your answers right in there. All right, moving on. So this is also in your PowerPoint. So if you can't see it clearly from this, you can also see it right in the PowerPoint or the Google Slides presentation that is available for you. So it says below are 3 scatter plots. Each one represents a data set with 8 observations. So the observations being each red point that is plotted there. The scales on the X and Y axis have been left off these plots on purpose. So you have to think carefully about the relationships. So again, it's not telling you what it is describing, but it does have 3 different plots, scatter plots, and sets of points plotted. So if we think about those, if one of these scatter plots were to represent the relationship between height and weight for 8 adults, which plot do you think it would be and why? So again, which one of these 3 do you think would be height versus weight? So we can put height as our Y and weight as our X, or vice versa, and think about it. So if someone is less tall, does that mean that most likely they will not be very heavy? Or that would be the first one. Or the second one here, if someone is really short, does that mean they would be extremely heavy? Or the third one here, is there really no difference? Sometimes people are heavy that are shorter, and sometimes they are heavy when they are taller. So that is what we're going to think about here. And if we think about it, scatterplot 1, again, just like we were describing, the weight or height could be assigned to either axis, just like axes. So like I said, as the height increases, so does weight. So typically that's how it works, right? Scatterplot 3, the weight or height could be assigned, and there's no relationship. So we expect to see the relationship that would follow scatterplot 1, right? The taller someone is, typically the heavier they are, although that's not always the case. And again, we can see that in this one. It doesn't always show that, but in general, if someone who is 7 feet tall is going to weigh more than someone who is 4'9" per se. So I would expect scatterplot 1 to be the one that makes the most sense. While a large population would likely show a relationship between height and weight, it is possible in a small sample no clear pattern would emerge. So again, I would say that scatterplot 1 is the one that makes the most sense. But again, if you can explain why, you can go with either of the other ones. All right, these are also on that same one. It says, if one of these scatter plots were to represent the relationship between height and SAT math score for 8 high school students or seniors, which scatter plot do you think it would be and why? So again, if you don't know yet what the SATs are, they are a standardized test that most people take before they go to college. And colleges use the SAT scores to determine whether you get in and whether oftentimes you get financial aid or money that will help you pay for college. So again, if we look at that one, which one of those do you think makes the most sense? That would be between your height and your SAT score. So do you think that if you are shorter, your SAT math score would be lower? Do you think if you're shorter, your SAT score would be higher? Or do you think it doesn't really matter? That would be scatterplot 3. So take a minute and you can put that in, and then we'll go over it at the end. And again, make sure you're telling me why. So if you're saying shorter people get worse SAT math scores, make sure you explain why. Or you're saying shorter people get better SAT math scores. Explain why. All right, let's move to number 6 now. If one of these scatters plots represents the relationship between the weight of a car and fuel efficiency. So if we look at these graphs again, the weight of the car, so the heavier the car would be the further on the x-axis, and the fuel efficiency, meaning if they were very efficient, it would be at the top, and if they were not efficient, it would be at the bottom. So the first one would be the lighter the car, the worse fuel efficiency they get. The second one would say the heavier the car, the worse fuel efficiency they get, or the lighter the car, the better fuel efficiency they get. And then the third scatter plot would say that there's really no difference. It could be totally random. So think about that one, and you're going to collect or select one of those scatter plots. So again, that is between the weight and the fuel efficiency. If you think about a specific example, a Hummer is an extremely heavy car. Do they get good fuel mileage, the miles per gallon, or efficiency? All right, and number 7. Which of these three does not appear to represent a linear relationship? Explain why you chose that. So again, which one does not look like a line, a straight line, a linear relationship would represent those points well? 1, 2, or 3, and why? All right, so if we talk about them, for the first one, the scatter plot that represents height and SAT math score, I would agree with what is on here, scatter plot 3. Again, there is no correlation between the two. Your height doesn't dictate how smart you are or what you would get on a standardized math test. So scatter plot 3 that shows the random relationships would be the best one there because there is no relationship between it. It's totally random. If we think about 6, the scatter plot that represents the relationship between weight of a car and fuel efficiency would be scatter plot 2. Typically, the weight of a car, the higher the weight, the worse they are with fuel efficiency. Again, or as this says, as the weight increases, the fuel efficiency decreases. So scatter plot 2 would be for that one. And then for number 7, scatter plot 3 indicates that there is no relationship, that a linear line or a linear relationship would not make sense for that one. You couldn't put a straight line that would average most of those points. They're all over the place. So I will leave this up for a little so you can copy this down if you don't have these written down already. And again, if you have a different answer, as long as you're explaining why you put that answer, it's all right. All right, going on to numbers 8 and 9. When a straight line provides a reasonable summary of the relationship between two numerical values, we say that the two are linearly related, or that there is a linear relationship between the two. So if we take a look at the scatter plot below and answer the questions based on this one. So scatter plot 1 here, it's talking about the number of cell phone calls and your age. And if you notice, it shows that around the age of 20, you get the most calls, and that decreases as you get older. This is just what they found with this data. So it says, is there a relationship between the number of cell phone calls and age, or does it look like these points are totally scattered? So again, does it look like a linear relationship could represent these, or are they totally scattered? And then number 9, if there is a relationship, does the relationship appear to be linear? So if we think about this, right, I put a linear line to try and show where the average of these points are. Does that look like it makes sense? Are there equal points on above and below that line? Yeah, it does, right? This could be represented by a linear relationship. And most of those points are pretty close to this line. So I would say it's a strong linear relationship. Again, the strength of the relationship is how close the points are to your linear line when you draw it. So again, yeah, there is a relationship and it is linear. As age increases, the number of cell phone calls decreases. And again, this is just on the data that's shown. This doesn't mean all old people or all young people get more or all older people get less. This is just in that graph right there. All right, if we check out this one, it says the moisture content, or the percent of moisture, and the flying time. So is there a relationship between moisture and frying time, or do the 2 points look scattered? So if the frying time is quick, it takes less time to fry something, does the moisture content higher? Yeah, it looks like as the moisture content gets less, it takes longer to fry those items. Right? There is a relationship, and again, it's not linear. This one looks curved, right? So if I go back, if I try and draw a straight line like we were talking about to represent a linear relationship, are my dots on both sides of the line? Oh, they're all below it, so that wouldn't make sense, right? We would have to draw some type of curved line to show this, which is non-linear, right? We could do something like that and it might make more sense. All right, and our last one here, scatterplot 3. So scatterplot 3 shows data for prices of bike helmets and the quality ratings. So is there a relationship between the price you're going to pay and how the quality of that item? So think about that. Does it look like there is a connection between how much you pay, which is the x-axis, and the quality rating, which is the y? So does it look like you could create a linear line that would represent these? And the answer is no, there really doesn't look like there's a relationship between them. They're totally scattered, right? And again, it is not a linear relationship because it's hard to put a straight line that would represent all those dots. They are totally spread out. So you would say this would be a weak correlation. It's strong if you can draw a line and it looks linear, and it's weak if the points are all spread out. So in summary, a scatter plot can be used to investigate whether or not there is a relationship between two numerical values, and the relationship between those two numerical values can be described as linear or nonlinear. And we talked about both of those. So your independent work for today is available on Khan Academy. So go ahead into Khan Academy and you can begin the scatter plots work. So there's 2 assignments that you can begin today, and you'll also have your asynchronous time tomorrow to finish those. So go ahead in and get started on those, and I will be around to your small groups to check in and just make sure you are good with what you are doing.